It is imminent to cross the barrier of advanced chip manufacturing process. The global semiconductor industry continues to slump, and many giants have half a foot into the winter. Even TSMC, the world's leading foundry with soaring net profit in the latest fiscal quarter, has warned of a decline in performance, cut investment budgets, shut down 4 EUV lithography machines, and encouraged employees to take vacations. To make matters worse, in October, Apple, Qualcomm, Nvidia, MediaTek, AMD and other major customers of TSMC cut orders. Aftershocks have not yet subsided, and TSMC's 3 nanometers, which has not yet been born, was temporarily cancelled by Apple. As the number 1 winner in the global advanced manufacturing process competition, TSMC has not long ago proposed a price increase to Apple with a tough attitude. Why is it showing its decline now? The reason for the market is that the global information industry has been aggressively scrambling to stockpile chips due to the chip shortage crisis, and has booked a lot of production capacity in major fabs in advance. This year, the demand for consumer electronics has decreased, and equipment manufacturers have struggled to sell goods. Therefore, the order cut effect was eventually passed on to the chip industry. The technical reason is that the performance of TSMC's first batch of 3 nanometers is too bad. Apple has strict requirements on the supply chain. However, TSMC's 3 nanometers not only has substandard performance parameters, low yield rate, but also high cost, which is no longer a good deal for Apple. In fact, TSMC's difficulty in 3 nanometers technology is actually a cruel situation that the global chip industry is currently facing. As the technology of silicon-based materials is approaching the physical limit, technological evolution is becoming more and more difficult. Only relying on the progress of the manufacturing process can no longer drive the improvement of the cost performance of the chip. Semiconductor companies that no longer follow Moore's law as their standard urgently need to find a new way to keep up with the surging demand for computing power. For the semiconductor industry in mainland China, the pressure is even greater. The U.S. government has intensified its power to block the development of the chip industry in mainland China. In the context of repeated suppression of advanced manufacturing-related technologies, exploring innovation paths is the most difficult problem that needs to be solved in mainland China. So, would chiplets be a good choice? However, in my opinion, chiplet may save some industries or companies, but it cannot save China's semiconductor industry. Is it true? Okay, in today's video we will talk about chiplet technology and the semiconductor industry in mainland China. Let's get started. Amid no let-up in US-China tech tensions, many industry professionals are pinning their hopes on the concept of a chiplet as a replacement for standard chips to help the country achieve greater self-sufficiency in semiconductor manufacturing. The chiplet is essentially a technology that allows an integrated circuit block to be interconnected with other ICs to form a larger, more complex chip. The chiplet has gained popularity in China as the country's semiconductor manufacturing is years, if not decades, behind international fabs such as TSMC and Samsung Electronics when it comes to making advanced chips. With US trade sanctions on the export of advanced chip technologies to China unlikely to lift any time soon, a number of Chinese researchers have argued that the chiplet could be an option for the country to forge its own path in advanced chipmaking. Even Huawei has recently joined its R&D camp. So, can chiplets really solve China's semiconductor crisis? What is the current development of chiplets in China? What opportunities and challenges are there? The ability to choose from a menu of small, highly specialized chips, and to mix and match them for specific applications and use cases, has been on the horizon for more than a decade. But the idea of integrating hard IP into a package really began gaining steam after the International Technology Roadmap for Semiconductors ended in 2016. Since then, chipmakers have been looking at a variety of different options to supplement scaling, which has become increasingly expensive at each new node below 22 nanometers. Chiplets have emerged as a way of extending Moore's law, or sidestepping it entirely, depending upon the application. At present, Huawei is looking at innovation in chip packaging, a technology related to the chiplet, in a bid to solve its own chip sourcing problem. Elsewhere, US tech giant Apple unveiled its most powerful in-house designed Silicon M1 Ultra chip in March, which adopted a chiplet architecture that interconnects two M1 Max chips to create a more powerful processor for its lineup of Mac Studio computers. Hao Qinfen, Secretary General of the China Computer Interconnection Technology Alliance, said in an interview posted on its website that China can use chips produced on the mature 28-nanometer node and pack the chiplets into a more powerful chip with performance and functionality on par with advanced 16 nanometers or even 7 nanometers products. China's leading fab, Semiconductor Manufacturing International Corp., is able to make chips on 28 nanometers and 14 nanometers nodes, but China's chip design firms, such as Huawei's HiSilicon and Oppo's design unit, rely on TSMC for 7 nanometers and more advanced chips, such as those used in the latest smartphones. However, some experts still have their doubts about the viability of the technology to solve long-term deficiencies. Dan Hutchison, vice chair at Tech Insights, a semiconductor research firm, said the chiplet as a semiconductor packaging technology cannot, on its own, solve China's predicament when it comes to advanced chip manufacturing. Hutchison, who described the chiplet as a new marketing term, said the idea is being played up in Chinese industry circles because the country is relatively good at packaging technologies. However, this does nothing to change the situation for manufacturing wafers in fabs because it is a packaging technology. Wei Xiaojun, a professor at Tsinghua University and a leading expert on microelectronics, saying that the chiplet is complementary to advanced chip-making technology, and not a replacement for it. Currently, many other international companies are looking to set new universal standards in chiplet technology, which would eventually allow members to use the same interface to facilitate the process from design to manufacturing. The Universal Chiplet Interconnect Express, an international consortium tasked with developing industry specifications related to chiplet technologies, was created in March 2022 with 10 founding members, including AMD, ARM, Advanced Semiconductor Engineering, Google Cloud, Intel, Meta, Microsoft, Qualcomm, Samsung, and TSMC. However, no Chinese company has joined the technology alliance so far. At present, China has started soliciting views on its own chiplet standard, which was drafted by the CSITA and China's Ministry of Industry and Information Technology. The global market for processor microchips that use chiplets in their manufacturing process is expected to reach $5.8 billion in 2024, rising ninefold from $645 million in 2018, according to Omdia, a market research firm, which said market size could expand to $57 billion by 2035. In short, due to the sluggish recovery of the global economy and the obstruction and interference of the new U.S. export control regulations on China's semiconductor industry, the global semiconductor industry division of labor system and layout are undergoing profound adjustments, and the road ahead for China's independent development of chips is more difficult. The current semiconductor industry in mainland China is weak in advanced chip manufacturing, lithography machines and other advanced equipment and EDA software, and strong in chip design innovation and packaging and testing. Learning about the above information, do you think chiplets will be the future of semiconductor industry? Can this new chip technology save China's semiconductor crisis? Or, is there any other technology that you think is more suitable for China's semiconductor industry? Please post your wise opinions in the comment area. Okay, that's all for today. Please keep following our channel and like our videos. I am Tech Teller, the person to tell you the opinions that worth spreading every day. Thank you so much for your continuous support. Your precious time with us is highly appreciated. See you.